Today we're going to talk about confidence intervals for two proportions. Comparisons between two percentages are much more common than questions about isolated percentages, and they are more interesting. We often want to know how two groups differ, whether a treatment is better than a placebo control, or whether this year's results are better than last year's. In order to examine the difference between two proportions, we need another ruler, the standard deviation of the sampling distribution model for the difference between two proportions. Recall that standard deviations don't add, but variances do. In fact, the variance of the sum or difference of two independent random quantities is the sum of their individual variances. Proportions observed in independent random samples are independent, thus we can add their variances. So, the standard deviation of the difference between two sample proportions is the square root of P1Q1 over N1 plus P2Q2 over N2. Thus, the standard error is the square root of P hat 1 Q hat 1 over N1 plus P hat 2 Q hat 2 over N2. The independence assumptions. The randomization condition. The data in each group should be drawn independently and at random from a homogeneous population or generated by a randomized comparative experiment. The 10% condition. If the data are sampled without replacement, the sample should not exceed 10% of the population. And the independent groups assumption. The two groups we're comparing must be independent of each other. Sample size condition. Each of the groups must be big enough. Both groups are big enough that at least 10 successes and at least 10 failures have been observed in each. We already know that for large enough samples, each of our proportions has an approximately normal sampling distribution. The same is true of their difference. Provided that the sampled values are independent, the samples are independent, and the sample sizes are large enough, the sampling distribution is modeled by a normal model with mean P1 minus P2 and the standard deviation equaling the square root of P1Q1 over N1 plus P2Q2 over N2. When the conditions are met, we are ready to find the confidence interval for the difference of two proportions. The confidence interval is P hat 1 minus P hat 2 plus or minus Z star times the standard error of the differences, where the standard error of the differences is equal to the square root of P hat 1 Q hat 1 over N1 plus P hat 2 Q hat 2 over N2. The critical value Z star depends on the particular confidence level C that you specify. Let's take an example. A survey of randomly chosen adults found that 36 of the 63 women and 42 of the 73 men follow regular exercise programs. Construct a 95% confidence interval for the difference in the proportions of women and men who have regular exercise programs. So the first thing we need to do is identify what P1 and P2 are. So I'm going to say P1 is the population proportion of women who exercise, and P2 is the population proportion of men who exercise. So now we go to step 1. We're going to check our assumptions and conditions. We have a simple random sample, it is stated. We're going to look at the population sizes, and hopefully they're greater than 10 times the sample sizes for both women and men, and we can safely assume that. We know that P hat 1 is equal to 36 over 63, which is 0.5714, and P hat 2 is equal to 42 over 73, which is 0.5753. So doing our condition for successes and failures, we have N1 P hat 1, that's equal to 36, and that's greater than or equal to 10. And N1 Q hat 1 is equal to 27, which is greater than or equal to 10. N2 P hat 2 is equal to 42, and N2 Q hat 2 is equal to 31, and they're both greater than or equal to 10. So the conditions have been met. Step 2, we're going to calculate the confidence interval. So here's our formula. Plugging in, we get 36 over 63 minus 42 over 73, plus or minus 1.96, and 1.96 comes from the 95% confidence, times the square root of 36 over 63 times 27 over 63, all over 63, plus 42 over 73, plus 31 over 73 over 73. So our interval is negative 0.1706 to 0.1628. Step 3 is our conclusion. We are 95% confident that the true population proportion difference between men and women who exercise is between negative 17.06% and 16.28%.